Okay, so for this last video, I want to talk about how to measure the volume of the metal, okay? Because that's another component we're going to need to get the density of the metal. Now, we're going to measure the volume of the metal here using the vial that you have where you're putting in some of those metals in to measure the mass, right? So let's think a little bit about the meaning of volume. Remember, volume is the amount of space that is taken up by a substance, okay? So if I ask you in this empty vial, what is the volume of the vial? You can say that the volume of the vial here is the same as the volume taken up by substance that fills up that particular vial. Well, in an empty vial, what is the substance? Well, of course, this vial is not really empty, but it's filled with air. So the volume of air in this vial is the same exactly as the volume of the vial because air takes up all the space in the vial. Okay, now let's take a look at this particular vial right here, which has some metal, and then the rest of it is blank. Okay, well, what is the volume of the vial here? Well, you think about it, the volume of the vial here is really just the volume taken up by the metal plus the volume that is filled by the air particles that fills up all of this other space that's not taken up by the metal. Okay, so that is actually a really useful idea to keep in mind when you're trying to calculate volume. Volume of a space is always equal to the sum of the volume taken up by each substance in that space. So for example, if I have a room that's filled with some furniture and there's a couple of people in there and then there's some air in there, the volume of the room is the same as the volume of all the furniture plus all the people plus all the air, right? That should make sense. Also, how are we going to use that information to figure out the volume of the metal? Well, simple. Let's think about this, right? If I just look at this particular container right here, okay, I can get the volume of just the metal if I were to do what? If I were to subtract the volume of just the vial minus the volume of the air in this vial. Okay, so in other words, I would have two different vials. One of them is empty. The other one is filled with metal with some air in it. If I were to take a difference between the volume of air in here and the volume of air in here, what I would get is the volume of the metal. Now, we're not going to use air here because air is not very dense. So the volume measurements of air here would be super difficult to do. We have to think about another substance that can easily be placed in the vials that has more density than air that would allow us to make the same type of measurement, which is that the volume of the substance when there's no metal in it minus the volume of the substance when there's metal in it would equal the volume of the metal. Now, if you've read the lab procedure a little bit, you know that substance that we're going to use is water. So the idea is very simple. It's exactly identical to what I just talked about in the previous part of the video. I'm going to fill this vial up with water. When I fill it up completely with water, then the volume of the vial is the same as the volume of the water. And then what I'm going to do is take out some of the water and fill it up with metal. So now the vial contains metal and all the rest of it is filled up with water. So now the volume of the vial here is then going to be equal to the volume of the metal plus the volume of the water that fills up the rest of that space. Now, using the concept we talked about earlier, in that vial where it's only water in there, the volume of the vial is the same as the volume of the water. In the vial where there's some metal and some water, the volume of the vial is the same as the volume of the metal plus the volume of the water. So if I were to subtract the volume of water in here minus the volume of water in here, what I'm going to get is just the volume of the metal. Okay? Now some of you might be thinking at this point, but wait a minute, now the concept makes sense to me, but how am I going to measure that volume of water? I don't have a particular marks on these vial that allows me to measure exactly how much water I put it in here. And again, how am I going to measure the amount of water I have in this one? And that's a really good question because how do I know how much water I have in terms of volume in this vial? Now, you can't measure the volume directly, but what can you measure? Well, you can measure the mass, right? You can measure the mass of the vial containing the water. You can measure the mass of the vial containing the water and the metal. How are those masses converted to volume? Well, this is a density lab after all, so of course we're going to use density to try to convert that mass into water. And so how are we going to do that? Well, it turns out that density of water has been tabulated at various temperatures. So the table is actually given in your lab procedure. So if I measure the temperature of that water in my vial, and I find that the temperature is 21 degrees, let's say, I know the density has to be equal to this number right here. So if I take the mass of the water I measure, divided by the density of water, then I get the volume of water. Okay, and you say, well, how do I get exactly just the mass of the water instead of including the mass of the vial in it? Well, it's simple. You're going to measure the mass of the water by weighing by difference. So for example, if I want to know how much water I have in here, I just need to subtract the mass I have in here minus the mass I have in here. If I want to know the mass of water in here, I need to subtract the mass in here minus the mass in there. Okay? Just one note about this experiment. It's crucial that you fill that water all the way to the top, because remember, our assumption is the volume of the water is the same as the volume of the vial. So if you have a bunch of space in the vial, then the volume of the water is not equal to the volume of the vial. So it has to be filled all the way to the top, okay?